So in this guide I'm going to explain how to use an Instack oscilloscope, and basically an oscilloscope is an instrument used to measure and analyze different waveforms, electromagnetic waveforms with a defined frequency. It is especially useful as it can show how a signal varies within a certain period of time. An oscilloscope displays the voltage in the y-axis and the time in the x-axis. At the bottom of the display, you can observe the channel, if it's channel 1 or channel 2, and also the volts per division or the times per division. You can also see if the signal is grounded or not, like that. And if the signal is set to AC or DC mode. More advanced settings such as probe settings and triggering information can be seen. So to connect the B and C connector, you basically have to match up the groove with the post, like this. Then just push, twist clockwise, and then it's... So now I will be explaining the vertical axis in the oscilloscope, where you can see channel 1 and channel 2. When the green light's on, it means that the channel, you can see it in the screen. You've got the position scroll button, which will move it through the y-axis up or down. The volts per division, which can vary from 1 millivolt to 20 millivolts. It just changed the volts per square, basically. And then the signal can be set to ground by pressing like this. You can also change the signal to AC or DC by pressing the button. And finally, if you push long, you will set the probe times 10 function, which I will talk about later. So in the horizontal axis, you can change the times per division by moving it like this, scrolling the button, which can vary from 0.5 seconds to 0.2 microseconds. You can also change the position in the horizontal axis by scrolling the button. You can set the magnitude on or off. Just switch it from 5 to 10 by pressing here the magnitude on, and then this. And then to compare your signal to the magnified one, you can press the out when it's on. Finally, you've got the XY button, which basically lets you vary the movement, the vertical and horizontal movement of the beam by varying the X and Y. Finally, you can also attach an external signal to trigger the source. So triggering is used to keep a wave stable. To do this, the beam must follow the same path each time it returns to the beginning. This means it must start at the same point each time. So here we can see that the wave's not triggered. So you can see, so now we're going to trigger it, which you would basically move like this, and now it's triggered like that. Also, the oscilloscope has a threshold in which the oscilloscope does not display a signal. Basically, the threshold can be moved from with the level scroll button here. So here's also the threshold that is not triggered here, and like that. It also has the hold off scroll button, which can be very useful for the flyback time, to hold the flyback time for longer. This is more useful for more complicated signals. The flyback time is basically the time the beam takes to travel from the end to the beginning of the screen. Now you can use different triggering buttons to trigger the source. So by changing the source, you can choose from which source you're using. So vertical just chooses the one you're using, so channel 1 in this case. Then you've got channel 1 and channel 2. Channel 2 here, and then the other two options you have is basically line, which compares it with the AC power source. This is useful when the waveform display is time related to the AC power source frequency, as you can recognize noise produced by the AC power source. And then the external mode uses the external signal to trigger the signal you're projecting on the screen, which is here, from where you would be. Then you can change the slope here, basically, which is just changing the the slope here. It's just changing the gradient. And then the coupling bottom has 3 options: AC mode, which eliminates any DC offset before adjusting the triggering point. Then the HRF mode eliminates the high frequency signal above 50 kHz, and the LFR eliminates low frequency signals below. So to display a signal, you would basically have to vary the time division and the volts per division. So here, obviously, you cannot see the signal; it's not displayed properly, as it should show a sine wave as it's connected to the signal generator. So basically, you will increase the time per division like this, and then trigger the signal, and just like that, and then the signal is displayed. One of the most common issues is to have the timestamp probe on or off for the correct resistance in the circuit measuring the signal. For high resistances close to 1 mega ohm, make sure to turn the probe times 10 on the probe and on the oscilloscope, as this will give the correct voltage. For small resistances, do not turn on the times P10 and make sure that the times 1 is selected on the probe. A typical problem is to have selected the wrong triggering source, the external, the line, vertical, or incorrect channel. Other problems might have been to not have selected the ground, which you should always do before measuring a signal. One of the most common mistakes is to not have set the wave correctly, and therefore might increase error when measuring the voltage or the time. Therefore, you should set the wave as in the second picture, not as in the first one. Also, make sure that you have set the wave to ground beforehand, so you know from where you're recording your voltage.